Hi, everyone, and welcome back to SciByte, Jupiter Broadcasting's weekly science podcast. My name is Chris, and joining me like every week is Heather. Hey there, Heather.
Hello there, Chris.
Hey, how are you doing this week?
Oh, pretty good. How are you?
I'm good. I'm excited because we're back in the studio doing an actual video edition of
are.
SciByte. And I'll tell everybody about that in just a minute, but do you want to tell people about what we have coming up on this week's episode?
Yes, we have a lot of updates on previous stories we've covered on Phobos-Grunt, on Curiosity rover, on some asteroid we talked about, on Neutrinos,
Yeah,
we're talking about
interesting.
Saturn, of robots, all sorts of stuff is in today's show.
Yeah, and so SciByte is a weekly audio podcast with one video release a month. So a lot of the stuff we're going to talk about is going to be updates from the weekly show. So if you are subscribed to our audio feed, you'll still get this video release with an audio version. And if you're just on one of our our YouTube site or one of the other video syndication places, you can see this. And if we pique your interest, head over to jupiterbroadcasting.com and grab the regular audio version. Yeah?
There are more about the stories that we're going to cover today.
Because we've heard a lot of people say, hey, we love the video version, so we want to put one out there a month for you guys.
Yeah.
So that'll be this. All right, now I'm going to get us in to the news. Heather, what do we have coming up on the news this week?
Well, we're going to update on Phobos-Grunt. That was the Russian spacecraft. It was supposed to land on one of Mars's moons,
Supposed
Phobos.
to is the key word, though, right?
Yeah, they wanted to scoop some dirt and bring it back.
That's all.
Yeah, they kind of lost track of it for a little while, which we talked about last time.
Yeah.
But what the good thing is, well, it was good news for a little while. It launched on November 8th. They finally heard some signal on the 22nd. There was a European Space Agency dish in Australia, and they heard some radio signals, but it wasn't enough to really make any sense of it. So the next day, they were actually able to establish two-way communication. They're able to talk to it, get some telemetry back, and they passed that on to the Russian Space Agency. I don't know if they were able to get anything of the telemetry. It was some sort of coding that they had that got lost either in the transfer from Australia to Europe to Russia.
Oh, no.
But some Russian stations on the 24th in Kazakhstan were able to pick it up, they talked to it a little bit, and they were just trying to establish what the telemetry was, what the problem had been, why the rockets didn't fire to send it off to Mars. Unfortunately, contact was lost again on the 25th. They haven't been able to call it back.
No,
Not
this
really
is
sure
looking bad,
why.
right? At this point, they're starting to say we could be looking at the possibility of this thing coming back down to the planet.
Yeah. Now, most likely it's going to splash into water, or it's not going to do anything. A lot of it's going to burn up. But, for a while when they had contact, they said, well, okay, so the option to go to Mars is closed. The window of opportunity is gone. Can we send it to the moon? Can we send it to an asteroid? Can we do something else with it? Even if it's completely lost as a mission, if we can talk to it and get the telemetry back, get the data back, we can at least see what went wrong and how to get that from stopping again.
How can we build this so it doesn't happen again?
Yes.
Yeah, it does seem like at least, while kind of a bummer that's the best they can get, it would at least be valuable.
Yeah. I've even seen some stories that indicate that the Russian government may try to go after some scientists if they can find of who's at fault.
Oh, really?
Yeah, they're like, people, you messed up. You made us look bad.
Yeah, they don't like that.
Not happy.
Yeah. This actually, I had a lot of hopes for this because this would have put something in orbit around Mars for like a sustained period of time, right? That could be... Well,
it had a couple of different pieces. The Chinese had an orbiter that would have lived in Mars.
Right.
And we have a few that have been there and have in the past or there now. But this mission would have landed on Mars's moon and brought back dirt, which would be the first time that we've actually had dirt scooped up and brought back other than astronauts shoveling in moon dirt and bringing it back in fancy buckets.
Right,
or
right.
Proper containers.
Moon dirt, schmoon dirt, I want Mars dirt.
Mars dirt. Well, it would have been close. It would have been rock around Mars dirt, which most likely would have been an asteroid, but
yeah,
we could have seen whether they were asteroids or they got chunked up from Mars.
Yeah. That is a damn shame. Yeah, that's right. I forgot that the Chinese were also sending a lot of their equipment, which was a big deal for them, too. It was like one of their first big things.
They were going to have, it was going to be their first Martian orbiter. that they had there, and so they kind of piggybacked on the back of that. So,
well, because everybody always thinks the Russians build great rockets, so you got a sure ride. They probably were.
They just don't have any luck with Martian missions. They've had a lot of different failures over the years. They just don't have any luck when they want to go to Mars.
I want to go to Mars so badly too, which is just the shame of the whole thing.
I know.
And
unfortunately, it might not be a good idea to ride Russian.
Well,
I feel bad, but
hey, at least they're making an attempt.
They are making an attempt.
You can't say the same about
us.
It
was a really awesome mission in the science that it could have done.
Yeah.
And I was hoping there for a while that they would establish communication just so that they could land on something. If they were able to maintain an orbit, then maybe some near passing asteroid would come and they could land on it, get some data, or maybe even scoop up from it and come back to Earth.
Yeah. Well, I mean, so it's not, the window of time is closing, but it's not closed as far as getting a hold of this thing and at least getting a data dump, right? Because we're not actually talking, like, it's not actually descending yet.
No, it's not descending yet. Currently, they have it, I've seen estimates anywhere from January to March for it coming down. Now, if they can establish two-way communication, then it depends. If it's such communication that they can keep it in an orbit, make it go to a stable orbit, and then just kind of hang out there until they figure out what they want to do, or if it's such that it's a game-ending problem, and they can bring it, if they have two-way communication, then they can choose where it comes down.
Right. Yeah. Then that'd at least be something too. That way it doesn't smash into a continent somewhere that's populated.
Very unlikely, but
I know. It's more likely it's going to hit the water. I know, but I just, if you can control
it still makes people feel a little bit better.
Yeah.
To know that you have a target.
This has been an interesting one for us to follow here on SciByte. So it's kind of come to a early conclusion for us. I think partially we were hoping for the show that we could follow this one for quite a while.
Yeah,
and report on it throughout the show for you. So we're kind of bummed personally for that reason too.
Yeah, there might still be hope for it, but at this point it may just be, yes, it's come down.
Well,
that would be the update.
I was given the U.S. a hard time about, well, hey, at least the Russians are trying to go to Mars, but NASA's doing it with their what they call like their laboratory, right?
Yeah, the Mars Science Laboratory, or the Curiosity rover.
Right.
And we talked about it last episode quite a bit. A big chunk of it. It actually launched last Saturday.
Yay!
Went up. Yay! They have a picture of it going up. They have a picture of it separating as it shoots off to Mars.
That's awesome. That is awesome. Yeah, in fact, we have a picture of it separating as it goes to Mars. These are cameras actually in space. Cameras in space of the actual unit up there, which is awesome.
Yep.
And you can see its solar panel unveiling itself, and there it goes. There it goes. It's separating.
Shoots off towards Mars.
That's really neat. So do we know what's the details on it? I know we've talked a little bit on the show, but I want to cover some of it for people that might just be tuning in.
Yeah. So its target landing date is August 5th of 2012. So it'll be a little while before it lands. But this thing is huge. It's 9 feet long. It's got a lot of different really strong equipment. It's going to look for water, for signs of life. It can measure down to 0.1% water density, up to 6 feet in depth.
That's amazing. Think about how sensitive that is for an automated piece of equipment.
Yeah. And it has the laser beam that it can shoot out and shoot a rock, laser beam, then read the spectrographic. Oh, I know. And it has different landing systems. So it's got the rocket pack, so it'll be able to have a more targeted landing zone.
Yeah, it's not doing the bounce thing that I think a lot of us have in our minds when we think about a lander rover landing.
Yeah, we've all seen the old animations of them bounce, bounce, bounce.
Yeah.
No, this one will separate. It has a little rocket pack, and it'll come down, and then it'll extend down a little rope. It'll land it very gently on the ground, and then the rocket will go away.
Much more sophisticated. In fact, if I recall correctly, when it is descending, it actually has a little camera built into the bottom of it, so we can take pictures of where it's landing. So it gets an idea of its lay of the land. It gets an idea if the territory is safe. Plus, the NASA gets a ton of aerial photos just to go over. I mean, it's like a win-win altogether.
Oh yeah, really so they can just get better resolution and also kind of start mapping out. Wow, this looks really cool over here. We got to go check that out quick.
Well, and I love that, like, before it even touches down, they're already just getting data. They're just already collecting it just as it falls to the sky.
Yep.
Oh, and here it is. If you're watching the video version, we're showing what that little camera would probably look like. Obviously, this is a CG rendering of it because it's not there yet. But
Well, yeah.
this thing's pretty sweet, Mars. This thing,
Yep.
this part that separates and it lands down. Does it take off later? How does that work?
Yeah, it's built in so that it lands the rover on the ground, and then the cable's able to tell that the rover's on the ground, and so it releases, and then the jetpack flies away to a safe distance.
And what do they do with the jetpack?
Sit it on Mars, use it as a dirt paperweight.
So if somebody ever got to Mars, there's just a jetpack sitting around.
Yep, there'll be a jetpack.
There's just a jetpack just sitting there. Nobody's got dibs on it.
Yep, the little Mars cartoon alien guy, he'll have a jetpack.
No, I'm calling dibs on that jetpack. Dibs. I call dibs. I call dibs.
You
Come
call
on.
dibs?
I totally call dibs on the jetpack. If they're just going to leave it there, I want it. There's no reason not to. So that thing it's going to whip around Earth and then slingshot out there, kind of like they wanted to do with the Are the timing of this with the Russian?
The timing is very specific. These happened at the same time for a reason. The planets align every once in a while, once a year or so, that they're close enough that it's easy and it's a quick jaunt over to Mars.
Right.
So it's like we can get it there quick. We don't have to worry about going around the other side of the sun or any kind of craziness. It's just kind of a straight path. Mars catches up with us for a little while.
One of the interesting things about this is that it's going to have a 668, right? Is that what it is, or something like that? It's a considerably longer operational lifetime than the older rovers, or it's like way longer, right? It's like years.
Yeah,
longer?
It's way longer. I mean, even it has a radioactive power source. So even 14 years down the line, it'll still have a significant amount of power. As the power decreases, you might have to stop using certain objects. So you might not be able to power the laser anymore, but you can still reach out and scoop or just take pictures and roll around. Even that's significant data.
The old rovers were solar powered?
Solar paneled, yes. And so that was a problem. They thought, dirt's going to land on it. It's going to build up. Now, the rovers both had a pretty good luck. One of them, they had dirt devils on Mars. And one of them actually had a dirt devil go over it, clean the solar panels completely off. And it was like nearly as 95% of the power they had on day one.
Oh, that's awesome.
And so they're like, hooray!
So you never know when a good windstorm will come through and clear off the solar panels on those old ones, huh?
Yep.
But with this nuclear reactor, it'll last.
Yeah, well, the old ones, they only have so much power, so they're only able to keep so warm over the winter.
Oh,
the sun is lower, so you have a chance of it not waking up.
Right.
This nuclear power one, it'll be able to stay just as warm in the summer as it is in the winter, and it'll be able to work year round. And
you had me pull up this photo here of the tires.
Yes.
Are these tires doing Morse code in the dirt, or what is this?
Yes, I spoke about this last time where they had specific holes and dashes in it to sort of mark out. What they did is they actually wrote out JPL in Morse code, which is the Jet Propulsion Laboratory, which is who made it.
Geekily awesome.
They made the tire tracks leave Morse code.
Oh my gosh. I love the level of deep thought that just goes into this.
Oh, yeah.
That's clever. And it also great shot because it gives you a perspective of how big this rover is compared to the old rovers. That tire is about as big as that person's torso.
Yeah, it's pretty big.
Yeah. That's going to be that thing's going to be fun.
Mm-hmm. And, one other neat story that I kind of read about it is there's a lot of autographs. We talked about it back at Jupiter at Night earlier this year, where you could go on and log on and enter your name, and it would be on a tiny little microchip.
Yes.
Going to Mars.
I did that.
The 12-year-old girl who won the contest to name the rover got to actually write her name on it.
Oh, cool.
And when they went to get approval, final approval for launch from the president, because they kind of have to, they kind of went. They kind of went off, huh? And they're like, by the way, if you sign this, we'll put it on the rover.
Oh, cool.
So it's a standing tradition to have presidents, vice presidents, top members of NASA to have some sort of signature tiny somewhere on the spacecraft.
Well, and you think, I said this in last week's episode of SciByte, and it's a little gruesome, but if something were to happen here on Earth and we were just wiped out, humanity was just gone, if another civilization did eventually come to our solar system, they might check out Mars.
And they'd see little pieces of us scattered on Mars.
And a couple of things on the moon, and they'd be like, so there must have been a civilization here at some point.
If something took out the Earth,
I was thinking like a disease or like, so like the just something where humanity's gone. But there would be like those would be some of the small records of us. You're right. If it was like if Earth blew up, it'd take the moon, wouldn't it?
Yeah.
Yeah.
If it's not taking out Earth, if it's just humanity.
Still gruesome. Still pretty gruesome.
Armageddon, always fun.
Yeah, yeah. So any other thoughts on this guy?
Well, no, I think that's about it.
All right. Well then, it's time to move on to the next story. There's a story in here about a molten lava rock that's hurtling towards the Earth, going to smash with us and turn us into one piling thing of lava, right?
Not quite.
Oh, no?
Not quite. No, not Lava World.
Oh, okay. Good.
We talked about this before. It had an asteroid, one of the quite larger ones, that they actually think they shot a spacecraft by it and it was able to take pictures. And from the transmission data and the arc of how the gravitational change of the spacecraft's path, they were able to tell that it had a density way higher than they thought it should have. And so they think it might have an iron core, a molten iron core.
Interesting.
Now, some of the new stuff is they were able to look at the data, and they were actually able to say that asteroid came from the inner solar system, the stuff that made Earth, made Venus, made Mercury. There are only 2% of the asteroids in the entire asteroid belt that are like this.
Wow.
And so this becomes suddenly far more interesting because this is an asteroid that shows us the stuff Earth was made of.
Right. And the stuff that's at the core of our planet.
Yeah, this is the kind of stuff that originally made all the inner planets. So we can kind of get a much better idea of what was close to the sun early in our solar system as the planets were forming. What did we look like? Mm-hmm. It'll help kind of understand what that is, maybe change some of our models, be able to say, oh, this kind of materials were here. If there weren't a lot of this radioactive or that, then it must have come in from comets or from other objects.
Right.
So we can kind of identify what started where.
What was the seed almost, right? Yeah.
Yeah.
And they're thinking if there's asteroids out there that have this molten iron core, then they could have simply smashed together, right? Is that kind of the thought? Like it seems
that's kind of one of the thoughts, is that in the early solar system that you get enough things clumping together that it suddenly has more gravity. So as it starts orbiting, more things come to it. It gets bigger and bigger and bigger.
Right.
And then once it gets so big and things are smashing into it, the inside is able to maintain a heat that's required to have some sort of molten core.
Right. And then that leads to all sorts of good things happening, right?
Yeah. like online shows about science.
Thanks to iron molten cores, you eventually get internet SciByte. Eventually.
Exactly.
It's not a direct causation, but...
A leads to C and figure out B.
I like where you're going with that. That's pretty good. So what's the end goal here with this kind of thing? Now that we just know about it, do we just kind of go, oh, that's interesting, or do they want to kind of take it from there?
No, they may take it from there. It suddenly means that because this is such a rare object, then this becomes of interest to future missions. We say, wow, that's really interesting. If we have a mission that can go to a asteroid, this is one of the ones we want to pick.
Right, okay. All right, so I see
if
what
we
you're saying.
have an asteroid mission that actually can fly by things or land on things, then this suddenly becomes one of the more interesting ones.
Definitely one of the candidates,
this is at the top of the list.
Yeah.
There's going to be a handful that you say, these are the ones we pick. That if we have a mission, those are the ones we want to fly by, those are the ones we want to land on and get instrumentation on and get data from.
Yeah.
And this suddenly becomes one of those more important ones to get data from.
That makes a lot of sense because you gotta narrow it down somehow.
Yeah.
And okay. You want to move on to the neutrino story?
Yes.
This is interesting because I think didn't this kind of come out like right about when we were talking about revitalizing and relaunching SciByte, and this is one of the stories I was like, this is definitely one to save for the show. And so now we've had a little bit of time. There's been some more information that's come out, but if I can set it up for people, I believe wasn't the initial thing is there was an experiment done, and the neutrinos ended up at the end result of the experiment just slightly ahead of the particles of light, right? So essentially they thought neutrinos were traveling ahead of the speed of light, which means they were going faster than light.
Yes.
Okay. So that's what I remember
Yep.
Set me straight. What's going on here?
So that's what it is. Well, they're making neutrinos pass through the Earth. It's actually because neutrinos don't really interact with matter. So they can fly right through the Earth, no problems. But they know the distance. Right. They know what's going on. I mean, they're taking in consideration how the moon flecks the Earth crust, all those kind of things.
Yeah. They travel, I don't know I don't know what this is in miles, but it's 732 kilometers, right?
Yeah.
Is how far they shot those light particles and neutrinos.
I believe so, yeah.
Yeah.
And so it arrived ahead of time, like 60 nanoseconds before they thought it should have, if they were traveling at the speed of light.
Well, 60 nanoseconds, when you're measuring something that travels at the speed of light, 60 nanoseconds can be significant. Yeah,
it is. And the fact that they actually measured it faster was the really crazy part. Now, I was very skeptical. Skeptical Mars was skeptical.
I recall that. That's why I kind of I've taken a skeptical stance to this story as well because of your skepticism.
Yep. Now, I still maintain some question.
Okay.
But they've had a repeated experiment that showed the same thing.
Doesn't that kind of change like everything we know about how nothing can go faster than the speed of light, and when you get to the speed... No?
Possibly.
Possibly? Because it kind of sounds like it does.
Well, yeah. Well, the point comes in is there's two main questions that I'm kind of seeing.
All right.
One, is there some unforeseen force or reading that's acting on the equipment or the experiment or the neutrinos or something that's happening that we don't fully see or comprehend? Like
Klingons or something.
Yeah, tractor beams, pulling them forward just a little bit.
Mm-hmm. I do believe neutrino emissions have been shown to be indicative of a wormhole in the area. So it could be that there's a wormhole.
Tiny little wormhole.
Yeah.
Through the Earth.
Right.
Sure. They could be taking a shortcut.
Okay.
The other idea that I saw was that do photons actually travel at the maximum speed of light? They interact with the universe just slightly.
It could be dragging them down.
Yeah, if they interact with the universe just slightly, it could be slowing them down. So that they go as fast as they can go, but the upper limit of the fastest speed that the universe will allow, maybe it's just that 0.0002% that the neutrinos are going faster.
Because the neutrinos don't have the drag of the universe.
They don't have the drag. They don't interact with the universe. They don't interact with the rock or anything.
Huh.
So there's the possibility of that, and I kind of liked that idea. Now, I'm going to take a little bit more step back from this.
Okay, all right, okay.
I'm not going to be super skeptical or for it. I mean, it does kind of, faster than the speed of light breaks a lot of science.
I kind of grew up basing a lot of things around like
Nothing
Star Trek's cool, but you can never really go faster than the speed of light. Yeah, that's that was it. That was the wall.
There's the speed of light and that's it.
Right.
You run into the wall.
Maybe eventually we'll have a set of warp drives. We'll have like neutrino drives or something. I mean, maybe there is something here to, I don't know.
Have a neutrino bubble around you so you can swoosh right through the universe.
Right?
Yeah.
That's how you do it. Okay. So you're starting to think that this might actually be legit.
Yeah, I'm starting to think that maybe the readings are legit. Now, this was at the same facility, just a different group. So once these readings happen at a different facility and a different group, I'll be much more keen to give it a lot more
The thing is, though, is this facility is so unique in terms of that massive conduit that they have. They can shoot stuff down and all of the instruments. I mean, it's not like you can just
It's not the only particle accelerator in the world. It's just the biggest.
Yeah. So they could do it on a smaller scale.
Yeah, they could do it on a smaller scale, possibly. But if somebody else in a different place sees the same thing, then it leaves a lot more credence to it. It makes it a lot more, especially in the scientific community. If you repeat an experiment and does the same thing in the same location, and a different group does the same thing, that's kind of one level of, that might actually, be something. Yeah. But if somebody else does it somewhere else and then gets the same results, then you really pique the interest and everyone goes, that may be true. Let's take a real look at this.
It definitely piques my interest. I want to stay on top of this one on SciByte.
Oh, yeah.
Because God, could you imagine how cool would it be just to have a show covering a story about the discovery that something can travel faster than the speed of light, and we get to talk about it. That's just really awesome.
Oh, yeah.
Just even that is exciting. Any other thoughts on this one?
No, I'll send myself a message that gets to me beforehand in neutrino Morse code.
Yeah, just instead of subspace radio, use neutrino radio or use a neutrino bubble and then just encapsulate it in that. Maybe eventually our computers can speak in neutrinos.
Yeah.
That'd be great. Speed things up. Now, we on SciByte, we have what we call the News Byte section where we chug through some stories in a little bit quicker format and also have extra links for you to follow. Before we go to that, though, I do want to mention the fact that it is the holiday season. People are out there buying things, and you can help support Jupiter Broadcasting very easily. If you go over to the wonderful, beautiful JupiterBroadcasting.com, anywhere on the site, if you scroll all the way down to the very, 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 very bottom of our website, you look down there, what we have right there is a support Jupiter Broadcasting while shopping at Amazon.com. And that, if you go there, will tag your shopping session with credit to Jupiter Broadcasting. Also, in the show notes, we have links so that anything you buy through ThinkGeek will also be credited to Jupiter Broadcasting. And a note to you UK viewers, because I've heard from a lot of you out there, and finally my wife Angela kicked my butt into gear and got me to do this. We've set up UK affiliates with Amazon, so whenever you see a product now link in our show notes, that should automatically work for either the US affiliate or the UK affiliate store. So thanks for thinking of Jupiter Broadcasting. Now you can shop at your favorite places, get your holiday stuff taken care of, and give us a kickback. Plus, when you're over at Jupiter Broadcasting, clicking on that link, why not, while you're scrolling down, right-click on an episode of SciByte and listen to it on the other tab while you shop. Then you get a little science while you shop.
Yep. I always like using that for Christmas shopping because it's like double the gift.
Yeah, that's right. A little gift to us, a little gift to whoever.
A little gift to family.
Plus, you always get
or for yourself.
Yeah, it is not. You feel good. You're like, well, then not everything I'm spending is going to waste. It's some of it's going to Jupiter Broadcasting. All right, now with that out of the way. It's time for the SciByte News Bite. What's up?
Yes. Well, Saturn has a huge storm on it. This thing, it started up a while back. It started back last year.
It's around for, it says here in your notes, 200 days in the making.
Yeah. This thing has been going on for 200 days. And at this point, it wraps around the entire planet.
It's actually kind of beautiful.
Oh, yeah. It's crazy cool. And one of the images that's there's one that's regular color. And there's one that looks a little odd in color.
Yeah. Yeah, kind of extra orangey or whatever.
Yeah, it's more science involved into its specific wavelengths. And on the left side, there's like a blue hole.
Okay, yeah.
And that's diving down. That's like almost Eye of a Hurricane style, where it's diving way down into the depths of Saturn and kind of pulling up or exposing some of the deeper parts of Saturn.
Ooh, cool. I've always been very fascinated by the gas giants because what's in there just got to be like in the core. There must be like a little bit of land or something, right?
Yeah, that's the big question. Is it there's some sort of core to them? But
I love this image you have here in the show notes that starts at December 5th, 2010.
You can see the storm progress and get bigger and bigger and bigger and eventually wrap around and start eating its own tail.
That is the storms that start up on these planets because, Jupiter has that forever storm on it, too. That's
it has the big red big red
dot.
spot and the little white spot circling it, too. But, yeah, the wind speeds on these are so much faster than we originally thought could be. And it's just because eventually we figured out the wind doesn't have mountains and trees to slow it down.
Right.
So they just go faster and faster, and they have such high wind speeds and these storms, and they just go crazy.
It's like if neutrinos were storms.
Yeah.
No drag, right?
No drag.
That's what it is, yeah? It's no drag, so they can just go crazy. And Well, that's a very, very cool-looking storm, and if you're listening to the audio version, you'll have to go check out the links in the show notes to that one.
Yeah.
So, all right, should we move on to this Gumby bot?
Oh, my gosh, yes.
Now, I don't want to be like Mr. Anti-Robot on the show because I think robots are kind of cool.
Yeah.
This one, though, kind of reminds me of a bug a little bit. Kind of grosses me out.
It did. I saw the video of this, and I was like, whoa, creepy and cool.
Yeah, I mean, it kind of looks like it crawls like a screwed up bug a little bit. And
they kind of got some of their ideas about these. A lot of these little squishy robots get their ideas from bugs or underwater life.
Iron Helix in the chat room is calling it a facehugger, and it does kind of look a little bit like an alien facehugger.
Yeah, there's one image of it. They have it down on the wire, and it reaches down. And it's able to grab an orange and pick it up.
Oh, seriously? So it's got some strength to it too, huh?
Yeah, well, it's funny because it's just using air bladders. So it's just pumping up certain ones and releasing certain ones.
Sure.
But it can crawl under stuff, it can go around stuff. And the idea is, for these kind of things, you can go into hard-to-reach cracks and crevices. And you can use it in disaster zones after an earthquake, when a building has gone down. And you can kind of take these robots and make them crawl and squish into crazy places and say, person here, come get this person.
It also looks like it would slowly and steadily crawl inside a human body if you needed it to. I mean, that could be for medical purposes.
Sure, if they got just a little bit smaller, or you had giant people.
Yeah, well, no, they'd have to get a little smaller, yeah.
Yeah.
Yeah, but
well, I mean, they have the little capsule pills that you swallow and it takes pictures.
Yeah. I like the idea of, being able to send this into an earthquake or something like that with different nooks and crannies of a building. And if they could even attach something like a camera to this thing eventually. Wouldn't that be? Something even like a cell phone camera. Something just really small. That way they could get a visual
feedback. Or even just a microphone.
Oh, sure.
Listening for, people banging on stuff. Because if you know that these kind of robots are there, then you'll make noise.
So this is
as often as you can.
Its official name is the Gumby bot. You weren't joking?
I don't know that it's officially the Gumby bot.
It does kind of look like a Gumby action figure a little bit, too.
It does. That's why I was like, it's Gumby bot. It's soft and squishy and it
So that was your name?
Weird.
I think Gumby bot should be the official name for this thing. I think that's a great name.
I saw one of the news articles mention it as Gumby bot, too, and I just loved that name for it.
Yeah.
But this is the people over at Harvard making crazy stuff. There have been other groups that have done these kind of soft, squishy ones. One group made it look like made it work like a caterpillar.
I can see that
these
too.
Kind of these bugs and these sea life that have very simple movements. These creatures have very small brains, so it's just very simple movements that can do a lot and get a lot of places.
Well, and doesn't it seem like probably with our current level of technological sophistication, that the first kinds of robots we're going to see are more things like this, more practical application robots. We're not going to see full humanoid, Rosie the robot making your breakfast kind of robots, unfortunately.
Yeah, they've got, I think they've got in Japan humanoid robots that could act as concierge and just sort of sit at the front desk and answer. The lobby is to your right.
Yeah, but an iPad could do that
The elevator
too.
Down to your left to the third floor.
Or a PC on a desk could do that. They're not doing anything that an iPad or a PC couldn't do.
Sure enough.
But these things, being able to, a cop, something this size, right? Let's just say like a first responder, like a medic or a cop, could keep a box of these in his trunk and then deploy them into a building, and with wireless communications and whatnot, they could get all kinds of telemetry back.
Yeah.
And they could, that doesn't seem like that's too far away.
Pinhole camera or, a microphone, and you could just sort of, if you could remote control them, they just have a little screen and you can just crawl your way in different places and look for these, for people, or, where's this, what's going on there.
I like this one, Mars. Curious to see where this one goes. Any other thoughts?
I don't think so. I mean, it's,
All right, well, you know what that means.
It
means it's time to jump into the SciByte time machine and go back in time. Oh, I hear it now, yep. It's not quite as magical in video form.
No.
But it's happening. There it is. All right, so what do we have in the science history for this week? So what we do on this part of the science calendar is we look back first on things that happened this week in science, and then we look forward on what's going to happen this week up in the sky. So, Heather, why don't we start with 1819, 192 years ago?
Sure. That was when watermarking on triple paper was patented by a gentleman who who put 3 sheets of paper together, and so it could have a watermark. And so suddenly you could have currency that you could hold up, and it was a lot harder to counterfeit.
Right. The watermark, huh? Oh, 1819. Well, that was followed in 1830, 181 years ago, December 6th. What happened then?
Yep. The U.S. Naval Observatory, the oldest scientific agency in the U.S. It was established by the Department of Congress. Its primary mission being U.S. Navy chronometers, charts, other navigational equipment. It's still doing a lot of stuff today to help, that kind of thing.
It was established in December 6, 1830. Interesting. Yep. Wow, that is historic. All right, well, let's talk about December 6, 1850. This is 161 years ago.
Yes.
Boy, we got a lot of good stuff in the 1800s this week.
Yeah. The ophthalmoscope. That crazy thing that the eye doctor shines in your eye. But it's able to diagnose a lot of different eye diseases. So you're suddenly able to see details of a living retina, diagnose eye problems, prevent blindness. You can see problems early and try to prevent them.
Right. Absolutely. That's a great medical. Now, one that's not such a great medical discovery, but you know what? A great Black Friday discovery.
Yes.
66 years ago. Apparently, science took a pretty big break between 1850 and 1945.
This week.
Yeah, this week. 66 years ago, the microwave oven was patented.
Yes, and all the microwaved Hot Pockets in the world rejoiced.
Yeah. I've eaten more microwave meals than I would like
Care to admit?
Yeah.
Yeah, I know that
Marie
feeling.
Callender's is good. What can I say? All right, 57 years ago, November 30th, 1954. What happened?
The sky actually fell. In Alabama, the USA, a woman named Anne Hodges was bruised in the hip and the arm by a meteorite that fell through the roof of her house, smashed her wooden radio, and struck her as she was laying down on the sofa. It actually was visible from 3 different states as it fell in the early afternoon, and it's like a huge bruise on her.
Wow.
Making her at that time, the only person to ever actually be hit by a meteorite. This wasn't a small one. I mean, it was a big chunk of a meteorite. There's some images in the show notes.
She okay?
Yeah, she was fine. She was able to walk away from it, but it had just a huge bruise on her.
I'll have to pull this image up here because I got to see this because this seems like... Yeah. I mean, can you imagine being like, so what happened to you last week? Got hit by a meteor.
Yeah, I got hit by a rock falling from the sky.
Big. It's like the size of a boxy box. That's how big it looks, like a boxy box.
It was big, and there's so you can see the hole in a roof. Now, in more recent times, there have been ones that, blast a hole through someone's roof and...
Oh, yeah, she got quite the mark on her.
Yeah.
Oh, boy.
Well, if you had a giant rock hit you, I'm pretty sure that you were happy that all you got out of it was a bruise.
Yeah, no kidding, right?
Even a giant bruise.
Yeah, I mean, I'd be kind of happy if all I got away with that was losing a single leg. That's, to tell you the truth, I mean, think about the distance that thing traveled just to bruise her.
Yeah.
Right?
Well, luckily her roof and the radio sacrificed themselves to slow it down. Right. Just a little.
Yeah, that's why you should always listen to podcasts, people, because sometimes your audio listening devices can save your life. All right, well, we've got one more here looking back. December 1st, 1997. This is just 14 years ago. That's
right. The planets aligned. 8 planets from our solar system lined up from west to east. You can see Pluto, Mercury, Mars, Venus, Neptune, Uranus, Jupiter, and Saturn, and the crescent moon. It was a fairly straight line that they all lined up.
Wasn't there some hoopla around
yes. There was a lot of end of the world hoopla going on.
Somebody's calling you right now to tell you about the hoopla. Say, let me tell you about this hoopla. It's crazy. I actually had a family member who was convinced that the planets aligning would cause gravitational pulls on the asteroids out in the asteroid belt and pull them into Earth, and that he wanted us to go to eastern Washington up in the mountains to prepare for an asteroid strike because all the planets were lining up.
Yeah, I heard a lot of that, and it was sort of, they don't make any gravitational pull now.
No, I know. And I remember after it happened, so that was sort of anticlimactic. Nothing happened.
Yeah. You get those moments in history.
Yeah, you definitely do. So that was 14 years ago, and it's funny because I do remember that. All right, well, that's looking back this week. Now, it's time to look up into the sky.
That's right.
Oh, this looks like a really cool one. I'll load up the visuals while you tell us about it.
Okay. So we've talked in the past, the sun has been a really busy place. There have been some, in the last month, there's been some filament eruptions, coronal mass ejections.
Yeah.
They led to some fantastic aurora, and there's a video in the show notes from the space station.
Oh, and it's so beautiful.
And looking at it from the space station gives you a whole new perspective because you can really get the vertical feeling of these aurora, that they're just really shooting into space, and you can kind of see the vertical waves.
I've never seen it from above. I just never really quite thought about the fact that it would extend out atop of the Earth too. It's not just inside the atmosphere. It almost looks like they could reach out and scoop some of it up.
Yeah, there's a couple of parts in the video where they're passing right above it or near above it, and it's just amazing.
It's so gorgeous. I want to put like this really great new age music to it and then just totally like meditate to it or something. Because it's like, look at this. Look, the Earth is just covered in this glowing.
It was popular background music for a lot of the people who got this video, and the very new age or soothing music.
It's very soothing to watch it. Also, what is very remarkable to watch is all the different lightning storms in the clouds as the space station flies over.
Yep, you can see all the cities, the lights from the cities, all these lightning storms and just flashes. And it takes one orbit, so 90 minutes into a 5-minute video.
God, this is so beautiful. It's got to be one of the most beautiful, in-orbit things I've ever seen.
Oh, yeah.
So
I definitely, when I saw this, I said, that's got to go into the video show. It's got to be brought up again.
Yeah.
That's just such a beautiful...
It was fun to cover it in the regular weekly SciByte, but to actually see this is really something.
Oh, yeah.
Mm-hmm. Now, we had seen it. We'd gotten a sneak peek of the video during the audio version, but we know that you guys watching the video version were able to see that.
Yeah.
Cool. Well, anything else on that one?
Well, there was this, on Black Friday, there was a solar eclipse.
Oh,
that was only really visible from the South Pole and New Zealand. But it was, solar eclipses, you have to realize that the moon changes its distance between us and the sun. So you can actually get them where there's the moon and there's a ring of the sun surrounding it.
Right.
This was one of those where it was a sort of partial. So it's got a ring of the sun around it, but not many people got to see it, but it was pretty cool.
Yeah, those are always neat.
Mm-hmm.
Those are always really cool. That was, what? That'll be, when was that? That already happened?
That was Black Friday.
Oh, Black Friday. Okay, all right.
So it was this last Friday.
Okay. So we have a few things coming up this week, right?
We do. All this week in the dawn hours, you'll see Saturn and Spica, which is one of the brightest stars in the northern skies, just 5 degrees apart, which will be about half the width of your fist held at arm's length.
I love it when you tell us about the stuff I get to look up in the sky.
Yes.
Saturn.
On Friday, the moon's going to hit its first quarter phase. And on Monday, December the 5th, Jupiter, our favorite planet, will be to the lower left of the moon at nightfall. And that'll be so bright that only the moon and Venus will be able to outshine it.
And that will be on Friday?
Monday.
Monday.
Monday
I'll
the
keep
5th.
an eye out for it. I want to remember specifically Monday the 5th. I got to keep an eye out for Jupiter. It is our namesake after all.
Yeah.
That's pretty cool. Now, we want to get some of your science questions or science feedback. If you have any thoughts or comments on some of the topics we've covered, email us, SciByte@JupiterBroadcasting.com. And also you can email Heather directly, Heather@JupiterBroadcasting.com. And of course, I am Chris at JupiterBroadcasting.com. Now, I encourage all of you to tune in every single week. We do this show live over jblive.tv at 7:30 p.m. Pacific. Now, before I sign us out of here, Heather, is there any other business you want to take care of?
No, just look at the show notes for other links and all sorts of more information and all the links to the videos.
Yeah, you definitely earn a belly clap with those show notes. Those are some of the most awesome show notes. If you guys have not seen the SciByte show notes, just go look at them and be amazed with the amount of information that is contained. And if you don't know where the show notes are, you go over to JupiterBroadcasting.com, you click on the episode that you want to watch or listen to, and if you just scroll down just a little bit on that post, that's where all the show notes are. And you can find everything we've talked about there. All right.
Yep. And feel free to make a comment, because I know we have a lot of smart people out there that have a lot of knowledge that necessarily isn't in my field of study. And if you want to make a correction or you almost got it right, go ahead and write us in.
That's one of the great things too about science is sometimes there can be different takes or different interpretations on data, and I always love hearing different viewpoints. Or if somebody wants to play off any of the topics we've brought up and maybe go even further with them, I'd love to read some of those in a future episode. So yeah, definitely leave a comment over on the show notes. Is a great place to do that, or on wherever else you watch this. Okay. All right, everyone. Well, thanks for tuning in to this week's episode of SciByte, and I guess you'll hear from us next week.